Ma'am, please continue.
Yeah. Uh, Good afternoon, everyone. Um, Myself, Dr. Babita from ICF Central Institute of Fisheries Education, working at the Assistant Principal Scientist in Aquaculture Division. So I'm very thankful to the organizers to give me this opportunity to talk to you on this national refresher course on current trends in veterinary and fishery sciences. So today I will be talking about a topic called sustainable and eco-friendly aquaculture technologies. We all know fisheries and aquaculture are evolving in a day-to-day basis, contributing very well to the GDP of domestic production in our country. And it is growing in a very good pace of very, very good rate of growth also. So it is projected as one of the food producing sector which can also lead to the protein security required for the ever-burgeoning population. So in that case, the aquaculture technologies also have to evolve so that we will sustain the requirement, we uh, sustain the environment as well as the economical and social requirement of the country as well. So in this regard, we face when we talk about aquaculture sector and its growth, we have the problem with challenges. We have the challenges ahead of us. We have shrinking land and water resources. At the same time, we have demand supply gap that's very high compared to the other some sectors. And specifically, if you see in the domestic sector and the freshwater fish production, so demand supply gap is also increasing in that. And cost of production in terms of feed protein protein main protein source in any aquaculture feed is fish meal. So fish meal is mostly we are taking it from the non-sustainable resources. Those resources have in the marine non-sustainable wild resources. So they will be non-sustainable in the future. So when as long as the requirement is high, increasing and intensification of aquaculture sector increases. So that time what will happen? The feed will cost very high compared to the normal compared to the current situation. So in that case, it may not be affordable for any culture sector. So the production cost will increase, means the sustainability issue will start in terms of economic sustainability. And then we also face a lot of biosecurity issues like pathogen introduction from nowhere. So is underwater culture is really we cannot observe what is happening exactly. So many times it will be a disease prone when we exchange the water, when we take new water, pathogen will be coming along. These are some of the issues what we are facing as we go ahead in enhancing the fish production. So the major test on intensification is to make it sustainable by reducing the pollution. So any sector, any industry will see the pollution trend of that particular industry, right? So in case of aquaculture, also the pollution trend is very high when you intensify the production system. So what we have to do, we have to see the technologies which are self-recycling or reuse. So we our dependence on fish meal and fish oil, like non-sustainable resources, also we have to reduce at the same time. So that even those things also will lead to add to the pollution when we go for alternative resources or reduction of these resources for itself will cause less pollution in terms of nitrogen and phosphorus to the open water. Normally, any traditional agriculture system or conventional farming system or intensive farming system, we will exchange the water to make it toxin free. So normally the toxic metabolites of any fish culture system is nitrogen metabolites like ammonia, nitrite, and nitrate. Ammonia and nitrite are highly toxic. When it is converted to nitrate form, it can be comparatively less toxic. So that is the advantage of this process of nitrification. So we aim at recycling the water by using the process of nitrification. And whenever you project a technology, it should be affordable to the small and marginal farmers also. You cannot take only the high end farmers only for any technology to be uh, adopted in our country. So when we talk about this kind of system, so we always talk about how to reduce the expenditure in pumping out the water and getting in the new water. During that time, we will give a free entry to the pathogens. So these pathogens will create a problem to the aquatic organisms. So how much ever you can reduce the water exchange, that much your sustainability will increase, biosecurity will increase, cost of production will reduce. So the new strategy for future growth is always lying in no water exchange and rather more recirculation and reuse of the water. Water as a resource, not as a waste. So recirculatory aquaculture system is the first one, it is only called as RAS. So RAS system is very well established in when we talk about aquaculture system abroad. There are many high value species are cultured in the RAS system. RAS system is nothing but we have to reuse the water, we will recycle, we will filter the water and recycle it. That's it. So here water, when many high value species like sole, turbot, halibut, channel catfish, trouts, and artichoke, all the salmons, all will be considered in the RAS system in the foreign countries. Most of them, most of the high value species are going in the RAS system only because there are regulations for environmental pollution at the high density farming is very strict and very high. So in that case, we have to go for the local recycling of closed cycling of the water. So we'll see what is RAS exactly. So recycling and reuse of the water using mechanical and biological filters. So it is an intensive land-based aquaculture system, you can see. Use only 10% of less water as replaced daily. Maximum 10% of water will be replaced, not more than that. That too we will see the transpiration loss. Then high production at minimum area. That is the motto of any intensive technology. High production from a small area. Rather we call it productivity. How much kg fish we can produce per unit area of 1,000 liters of a cubic meter. So best is suitable, this kind of high-end technologies are best suitable for high value. Any species which is having any value above 200 to 250 rupees a kg only can be for this RAS or any intensive farming system. So in nutshell, we'll have a grow tank, the fish waste, and the uneaten feed will be transferred to a solid removal system. The solid removal system can be normally small or marginal farmer who is using that system, they will use a sponge filter or mechanical filter. In the form of mechanical filter, they will use a filter bags and remove the waste. So a daily removal of the waste. But if we go for a medium to high sophistication, we will have a solid removal system. It is mainly called you can say a drum filter. A rotating drum will be there. Through that drum, the water will be circulated. It is centrifugal force. The solid waste will be going towards the side and solids will be removed separately. And the water we can take it back. And from there, the water will be going to a biofilter. Biofilter, we already discussed about the nitrification process, ammonia to nitrite to nitrate conversion will be happening in the biofilter. The biofilter can be having a filter media. Filter media is anything corrugated plastics media is available. You can buy anywhere. So they will have a beneficial. They'll be actually we should have a biofilter maturation time. We should dip it in a already existing culture system or in a pond. We have to keep it for 1 week so that a layer of bacterial biofilm will be formed in each of this plastic matter. Then we can use this as a biofiltration medium. At the same time, we have to provide oxygen. This is an oxidative aerobic process. So this nitrification happens. Ammonia, whatever ammonia is coming, which is very toxic to the fish, will be converted to nitrate by nitrification process. And how well it can be done, how well your biofiltration system is, unit is aerated based on that your nitrification will be better. After that, the water will be going for a degas. So here most of the oxygen will be reduced to 70% reduction will happen. So we have to inject oxygen to form oxygen. And it is called carbon dioxide stripping. Carbon dioxide will be stripped and oxygen will be induced. Then here we have done only for the dissolved solids and suspended solids. First suspended solids is removed. The second biofiltration we remove the dissolved solids. And then third is we have removed the carbon dioxide and added oxygen. Now fourth step is we have to remove the pathogen. So for removing the pathogen, what we do is we will add either ozone or UV filters. Any UV filtration capacity with the capacity as per your requirement of the tank unit, you can go for filtration unit. And for filtered water, this is mainly for removing the pathogenic organisms. Okay, any bacteria, virus, and all. So then it will go to the water will be recycled back to the ground. So this is a nutshell the recirculation. So these are the components of which we already discussed. Fish rearing tanks. From there we'll go to um, Ponds mechanical filter. From there it will go. This is a biofilter tank. We can a small system where we can see the bioballs, or it is available corrugated plastic material, biofilter material we can get anywhere. From there it will go to ozone or UV treatment, and it can go for the aeration or oxidation, oxidation or removal of carbon dioxide. So depends upon the requirement. We can go for if it is a local recirculation, like it's a pond water we want to recirculate, we can have a local recirculation. Now nowadays in Dutch Netherlands, they are following a model recirculating uh, closed system. Okay, in most of the salmon or trout farms, what they do, they will have a sedimentation cone. They use a sedimentation cone. The water will be coming with a low pressure to that and settle there, and they will be allowing a settlement time. From there, water will be pumped to some of the screens. The screens will remove rest of the solids, and then it will be going to actually what they will do, they will have a wetland system. That to that wetland, it will be a constructed wetland. So what they will do, those plants will be planted on the trenches, and there will be trench and a trench system. In the trench, water will go, and above raised platform, the plants will be there, big plants will be there, trees will be there. Those they will take out the most of the nitrogenous matter and circulate it back into the this back into the pond. When we are doing in a bigger, very big setup of system where we cannot go for a closed recirculation, they do local recirculation. So when seeing as a component, you can have a large sediment settlement, suspended solids we can remove by even sand filters. There are sand filters available. They also remove the suspended solids and very fine solids. If you see some of the marine ornamental fish breeding units, fish rearing units, and all, we can see cartridge filters will be available. They're very fine. They'll remove very fine suspended solids also, like up to 1 to 20 microns. 20 to 100 microns, sand filter will remove. More than 100 microns, bottom siphon of settlers will remove. And if it is dissolved impurities like ammonia, carbon dioxide, and other toxic waste will be removed by large biofilters. And bacterial load will be removed by or organ. So you can see the mechanism.
Hello, Babita ma'am, are you there? Hello.